estimating the slope of a tangent line given an equation using the secant method, number 1. Quick review of previous information. Here's a graph of y is equal to x squared. I know it's not very exciting, and what we want to do in this video is find the slope of the tangent drawn in at this location, which is in blue. And in order to do this, I'm going to use a secant line. Here's the idea. This equation here represents the line drawn here in purple, which is the secant. And as I approach, notice the slope changes. It gets closer and closer and closer to the point of tangency, and you can see there's not much of a gap. This works great with graphing software, but we do expect that you're able to do this by hand, and that's what I'd like to show you next. So we're going to take the same equation, y is equal to x squared, and we're going to be using our graphing calculator to help us. I typed in y is equal to x squared. I've reduced the window so we only really want to look at that first quadrant when it produces a graph that looks like this. So x is equal to 1 is going to be approximately in this location, and I'm going to show you how to actually hand calculate an estimate of the slope of the tangent line. Here's an image of the same graph we saw on the screen, and what I've done is I've made a drawing of the tangent line at 1, which is located at this position right here, and then also to go along with that I drew in a secant line, and I drew in that secant line from 1 to 1.5. Now I know that if I choose this point closer, I'm going to get a better answer. So I'm going to pick some numbers that are going to work pretty well. Okay, I'm going to choose the time values, or I guess for our purposes, since we're not dealing with time, is why don't we go x is equal to 1 to 1.5. That's what we have now. Would shrink it to 1 to 1.1, and then even further to 1 to 1.01. And what we should see as we progress through this, that our numbers, as we get smaller and the numbers closer together, will give us a better end estimate. And what we're going to do next is we're going to use our calculator to help us with some of these numbers. So what I've done is preset this up. I went into my table settings and I changed my independent variable to ask. And I like this because you can type in whatever you want. And then under that table, I simply went in from there and then just typed in the values 1, 1.5, 1.1, and 1.01. And then you can do these by hand, you can use a graph and trace them, but this is a nice slick way to get them all in one table. So here's what I did. I took the table from the calculator, I wrote down the ordered pairs to kind of have this easy for you to see, and then the next thing we're going to do is simply use the slope formula to calculate the slope between these pairs of points, and we'll see what happens from there. So what I did here first is I used the ordered pair 1, 1 and 1.5, 2.25, and that's representing the one that I had already drawn in, the secant line. Here's the work, and you end up with a slope of 2.5. Now the next thing is I'd use 1 to 1.1, which would get me a little bit closer. The values indicate that slope estimate would be 2.1, and I get really close, 1 to 1.01, and then I end up with a slope of 2.01. And you can see as these numbers get closer together, these numbers approach a value of a slope equal to 2. Let's check how good our answer is. So we left this off at 2.1 before, and what I did is I zoomed in a few times. So let's see if we actually get a little bit closer if we do approach that number of 2. As I do this, you can see I go from 2.1 on that side. On the other side, it's 1.9. So it looks like that number of 2 seems pretty legitimate for this slope of the tangent. Let's go in a little bit more. I zoomed in a little bit closer. You can see as I get super close, we're at 2.01x. In summary, whenever you have a function that you need to estimate the slope of a tangent line, let's say in this situation it's going to be at x is equal to 3. What you can do is choose a point that's close. It could be 4, 5, 6, whatever you want. I would probably recommend you could even start at like 3.1 and then just work your way in. Go from 3 to 3.1, go a little bit closer, 3.001. And you could even go as far as 3.0001. You're going to run into some calculator issues, but as long as this point approaches that one, you're going to get some really good estimates.